So in section 12.4, we're looking at solving 3 equations and 3 variables using matrices. You could do this with 2 equations and 2 variables also. But by using matrices, we just are agreeing that we're not going to write down all these little variables. So we're not going to write down the x's or the y's or the z's. In fact, we're not going to write down the plus signs or the equal signs either. We're just all going to agree that the first column will be numbers that go in front of x, the second column numbers that go in front of y, the third column numbers that go in front of z, and a dotted line will take the place of the equals, and then we'll put the numbers that go to the right of the equals. So first column 1, 1, 1, second column 1, 2, 1, third column 1, 1, 2, dotted line where the equals go, and last column 9, 14, 10. So this is an abbreviated way of writing your 3 equations and 3 variables so that you don't have to write so much. So we're going to do the same things we do with 3 equations and 3 variables, only we're not going to write down all the letters or the plus signs. You will have one problem on your test to solve like this. I think I did a 2 equation and 2 variable so that it wasn't too long. And then some people really like this method and use it ever after once they learn it. Except for the one problem on your test, it's up to you how often you want to use the matrices method. Okay, so when we're solving for 3 equations and 3 variables, we first get down to 2 equations and 2 variables, right? So let's do that with the matrices. We're going to get the x's eliminated. If the x's were eliminated, there would be zeros here. So we want to get zeros here. And we would do that by subtracting one equation from the other. So I'm going to do that. I'm going to subtract. Okay, so I'm going to say, I'm going to write the first 2 rows down just how they are. 1, 1, 1, dot, 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 9. 1, 2, 1, 14. And now on this last row, I'm going to take and subtract. Okay, this row is going to be subtracted from this row up here. So row 3 will be subtracted from row 2. So 1 minus 1 is 0, 2 minus 1 is 1, 1 minus 2 is negative 1, 14 minus 10 is 4. Okay, so we had row 2 minus row 3 went right there. And then double check your arithmetic just like you would if you had written it all out. All the x's and y's and z's, you would want to double check your arithmetic. So 1 minus 1, 2 minus 1. Okay, and then this row represents, this third row represents y minus 1z equals 4. And it's what we would get if we took equation 2 and subtracted equation 1. We'll get a x eliminated in the second row as well by taking row 1 and subtracting row 2. So now I'm going to write the first and last rows just the way they are. So first row 1, 1, 1, dot, 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 9. Bottom row 0, 1, negative 1, 4. And now in the middle here, I'm taking row 1 minus row 2, and I'm writing that down here in the middle. So row 1 minus row 2. 1 minus 1 is 0, 1 minus 2 is negative 1, 1 minus 1 is 0, 9 minus 14 is negative 5, and I double check the arithmetic. Okay, so now what we have here in these last 2 rows, we have 2 equations with the same 2 variables. We have negative y plus 0z equals negative 5. And in the last row, 1y minus 1z is 4. Now, oftentimes at this point, you would work to get a 0 right here as well, meaning you would be down to 1 equation with just 2 zeros right here, so you'd have just 1 variable left. We actually have that going in the middle one. But just to show you how it's done, we'll work to get a 0 here again, okay? So I can do what I want to get a 0 here, except notice if I use the first row, I'm going to undo my 0 right here. So I'm not going to use the first row. If I want to get a 0 here, I will work by adding the second row to the third row and putting the result in this third place. So let's write down the first two rows just the way they are. 1, 1, 1, 9. Oops, forgot my dot, dot, dot. Second row, 0, -1, 0, -5. And now the third row, I'm taking row 2 plus row 3, and I'm putting it in the third row. So as I do that, I have 0 plus 0, -1 plus 1, 0 plus -1, and -5 plus 4 is -1. Once you have reached the point where you have your third row has a 0 and 0 in the first two places, and your second row has a 0 in the first place, in other words, you have this little triangle of zeros, you can take these back out of the matrices and make them into equations. Okay, so we're going to say this is -1 times z, and then the equals for the dotted line equals -1. And then the second row, we'd have the -1 times the y plus 0z equals -5. And then the first row, we'd have 1x plus 1y plus 1z equals 9. So we take it back out of the matrices, and now it's real easy to solve, right? I just take this last equation and divide both sides by -1, so we get z equals 1. The second to last equation, I go ahead and divide both sides by -1 also, so y equals +5. And then I can take the first equation and find x. So x plus 5 plus 1 equals 9. X plus 6 is 9, so x is 3. So the ordered triple is 3, 5, 1. So when you're working with matrices, all you're doing is leaving out the variables and the equal signs and the plus signs. And then you're working row operations, which is adding or subtracting two rows, or you can multiply a row by a constant before you add or subtract. And when you do that, you're trying to get these 3 zeros right here. So sometimes you have to multiply a row by a number before you add it to another row, so that you do get the zeros where you want them. So once you have these 3 zeros here, then it's easy to take the equations back out of the matrix and put the x's and y's and z's back and see, oh yeah, this is my x, y, and z. So some people love this method, some people don't love it. Okay, learn to do it well enough so you can do 2 equations with 2 variables for the exam.